Hi everyone! Today we will be solving a typical solubility problem. The problem reads, one method of mining gold is to extract it through the process of cyanidation. Mine ores are milled and treated with aqueous cyanide solution to produce a gold complex ion, AuCN2-, which is very stable. Given a sample of AuCl, what is the solubility of AuCl in each situation? Situation 1 being in pure water, and situation 2 being in a 1.68 molar solution of NaCN. But before we begin, it is important to know what KSP, Kf, and solubility actually mean. So I've provided a couple of definitions right here. Solubility is defined as the maximum amount of solute that can dissolve in a specific amount of solvent. That basically represents a level at which a solute dissolves in a solution. And according to ChemWiki, KSP, or your solubility product constant, is the equilibrium constant for a solid dissolving in an aqueous solution. And Kf, your formation constant, refers to the formation of the complex ion from a hydrated ion. And now that we know what this stuff means, we can actually solve the problem. In part A, we are solving for solubility in pure water. So what you want to do first is write out your reaction breaking up into ions. And it would look something like this. You have AuCl solid going to Au plus aqueous plus Cl minus aqueous. And right below this, you would set up your ice table, and you would have initial concentrations of 0 for both your ions, and you're adding your solubility S to each ion. It's only one S because the ions have a coefficient of 1. And as soon as your ice table is done, we can write out our KSP expression as products over reactants raised to their coefficients. But remember to not include solids and liquids, and that's why our KSP is equal to the concentration of Au plus times the concentration of Cl minus. In the problem, we're given KSP to equal 2.0 times 10 to the negative 13, in which we can directly plug into KSP. As for Au plus and Cl minus, we are plugging in S for each. Now, through simple algebra, you can solve for solubility. Punch up these values into your calculator, and you should get solubility to equal 4.47 times 10 to the negative 7 as your final answer. Now, that was your solubility of AuCl in pure water. How would you calculate your solubility in a 1.68 molar solution of NaCN? So we're given that log Kf of AuCN2- is equal to 38.3. So we want to find Kf by itself. So what we would do is raise it as an exponent with base 10, and doing so cancels out the log, and you should end up with Kf equaling 1.995 times 10 to the 38th. And if you guys remember earlier, Kf is defined as a formation of a complex ion from a hydrated ion, also known as an ion formed from the presence of pure water. So that's why you go back to the first part of the problem and rewrite your reaction. The next step is to write a second reaction involving the complex ion, but this time we have the ions of the complex forming the actual complex. You add up the two reactions and you get this, and as you can notice, the Au plus aqueous cancels out with the other Au plus aqueous. Beneath this reaction, you set up your ice table, and we're given an initial concentration of 1.68 for Cn from NaCN, and your sodium is actually a spectator ion, so it doesn't directly take place in the reaction. By definition, this is how you would set up your K, which is KSP times Kf. However, you can't solve for solubility this way because you're given an initial concentration of 1.68. If you do it this way, you would actually end up with a negative value, meaning your reaction has been completed. Instead, what you do is you take your 1.68 and you minus 2s, and you set it equal to 0, solving for s, and your solubility should equal to 0.84.